Hey everyone, welcome to The Explainer. If you've been paying even a little bit of attention to the tech landscape as of mid-2026, you already know we're standing right in the middle of a massive revolution. AI is absolutely no longer just this passive thing that chats with us or, drafts a quick email. It is actively and autonomously doing things. We are moving away from tools that constantly need human prompting, right, towards independent systems that can actually execute complex goals all on their own. So today, we're going to unpack exactly how this works by demystifying Agentic AI and really looking at how it integrates into the modern enterprise ecosystem.
Okay, let's dive into this. For the last few years, we've all been totally fascinated by large language models. You ask a question, it summarizes a text or generates some code. Amazing, right? But seriously, what happens when AI stops just talking and actually starts acting? We are transitioning from just chatting with passive bots to literally deploying autonomous robotic coworkers. Just imagine an AI that doesn't just tell you how to solve a problem, but goes out, fetches the data, uses the software, and just completely solves it for you. To truly grasp this massive shift today, we're going to use a corporate ecosystem metaphor. Think of this explainer as your brand new onboarding manual for the future of work.
So here's our roadmap for today. First, the anatomy of an AI agent. Second, the multi-agent ecosystem. Third, how AI agents communicate. And finally, guardrails and AI safety.
All right, jumping right into Section 1, the anatomy of an AI agent, our individual worker.
The best way to really understand Agentic AI is to look at how it's different from the traditional AI we're used to. Our sources define Agentic AI systems as autonomous entities that perceive their environments, make decisions, and manifest agency to achieve specific goals. Traditional prompt and response chatbots, well, they just sit there and wait for you to tell them exactly what to do. An AI agent, on the other hand, is given a goal, and it figures out the steps to get there all by itself. Imagine handing off a complex project to a colleague and never having to micromanage the steps. That is agency.
The absolute secret sauce making this possible is a mechanism called the Thought, Action, Observation Cycle, or REACT prompting. Think of it like a robot assigned to clean a messy room. It doesn't just blindly flail its arms around, right? First, it has a thought. Okay, I need to pick up items from the floor. Then it takes an action. It physically picks up a toy. Next, it makes an observation. All right, the floor is clear of large items now, but it's pretty dusty. That observation then feeds directly into its next thought. I should probably turn on the vacuum. It continuously reasons and acts in this real-time feedback loop.
And this brilliantly illustrates why this is such a game changer. Let's look at a super simple math problem. If I ask a traditional model, I have 10 apples, I give away 3, how many are left? It just spits out 7 apples. Boom, that's a static answer. But an agentic LLM using React, it actually exposes its reasoning. It says, thought, I start with 10 apples. Action, I need to subtract 3. Observation, the result is 7. By exposing this internal reasoning process, the AI can catch its own mistakes. It can go use an external calculator if the math gets too wild, and it adapts on the fly. It's not just retrieving some memorized answer, it is actively solving the problem in real time, step by step.
Moving on to Section 2, the multi-agent ecosystem, or what we'll call the department.
Because, let's face it, a single worker just isn't enough for complex enterprise tasks. This is where we enter the realm of multi-agent systems. These are networks of multiple autonomous agents that interact, coordinate, and collaborate to achieve collective goals. Microsoft's VP of AI agents actually noted in our sources that it is incredibly hard to create one single, flawless process and try to squeeze it into one mega agent. It just doesn't work well. Instead, breaking complex tasks into distinct, smaller parts significantly improves maintainability and reliability. Just like human businesses, AI thrives on specialization.
So what do the jobs in this AI department actually look like? Well, the research breaks them down into 3 highly specialized roles. First up, you have your worker agents. These are your frontline executioners. They're the ones extracting data, writing code, or drafting reports. Second, we have service agents. These are kind of like your shared IT and QA utilities. They enforce compliance, run diagnostics, and even act as healing agents to go in and fix errors made by the workers. And finally, there are support agents. This is your management oversight, the ones tracking the whole workflow without actually getting their hands dirty.
But look, you can't just put a bunch of specialized workers in a room and expect pure magic. You need management. In AI, this is known as the orchestration layer. Think of this as your overarching corporate structure. You have planning and policy breaking down those big, high-level goals. Then execution and control actually directs the traffic so agents aren't just duplicating each other's efforts.
State knowledge acts as the company memory, keeping everyone on the exact same page. And finally, quality and operations step in to verify the final output. This whole orchestration layer ensures your shiny new team of autonomous agents doesn't just go rogue or talk over one another.
And the real-world results of this multi-agent architecture? They are honestly staggering. Our sources highlight this amazing case study in the banking, financial services, and insurance sector. A mortgage lender deployed a multi-agent system where one agent handled document extraction, a completely different one did the risk analysis, and a third verified the compliance. By breaking the workflow into these specialized, tightly orchestrated roles, they achieved loan approvals 20 times faster. And if that wasn't enough, they simultaneously saw an 80% reduction in processing costs. I mean, that is the raw power of the AI department in action.
All right, Section 3, how AI agents communicate. Think of this as internal communications.
If you have an entire department of autonomous bots running around, they desperately need a way to talk to each other and access their tools securely. So the crucial point is understanding the difference between the two main protocols that govern all this communication. On one side, we have the Model Context Protocol, or MCP. Think of MCP as the ultra-secure bridge to the outside world. It's the standardized way an agent securely requests access to external tools, like a CRM database or a calculator. On the flip side, we have the Agent-to-Agent, or A2A protocol. This is their internal language, basically the company's Slack channel. A2A is exactly how peer agents negotiate, delegate tasks to one another, and share intermediate results entirely without needing human intervention.
And that brings us to our final part, Section 4, Guardrails and AI Safety, our HR and Compliance Department.
Okay, pause for a second. I really need you to lean in and listen closely here, because we are definitely shifting gears. We've spent this whole time talking about massive efficiency gains, but when you give software autonomous agency to make decisions and use real-world tools, the risks of unconstrained autonomy are absolutely terrifying. The sources are incredibly clear about the severe operational dangers we're facing here. Look, it is one thing for a standard chatbot to hallucinate a fake historical fact in some blog post, but what happens if an autonomous financial agent hallucinates a disastrous day trading strategy and just executes it across thousands of live brokerage accounts? No way, right? Furthermore, the research specifically highlights long-term planning agents, or LTPAs. These are systems capable of executing goals over extended timelines. Without strict guardrails, an LTPA might optimize its goal in a way that completely ignores your compliance protocols, or even worse, prioritizes its own self-preservation, literally hoarding computational resources just to ensure it doesn't get turned off.
To prevent these rogue, sci-fi nightmare scenarios, organizations absolutely must implement comprehensive AI guardrails. The first pillar here is governance and risk assessment. Before a single agent is ever deployed, enterprises need AI councils requiring strict safety reviews. You don't just hand an agent the keys to your company's kingdom on day one. You start out by mapping potential risks, creating mitigation plans, and testing these agents purely in low-risk use cases, using non-critical, completely anonymized data. Let's move to and see how this builds. This governance feeds directly into the second pillar, multi-layered technical controls. This is where you actually hard-code the safety mechanisms. It includes setting strict prompt templates that act as rigid blueprints, dictating exactly the structure of input and output allowed. It involves external validation checks, topic control mechanisms so the agent can't be distracted into unauthorized areas, and jailbreak detection to prevent malicious users from manipulating the agent's core instructions. The most advanced systems out there even use dynamic guardrails that self-evolve their security measures in real time as brand new threats emerge.
And the final pillar is operational resilience. This is all about maintaining safety in everyday, minute-to-minute workflows. It prioritizes accuracy through topic classification and safety through continuous toxicity detection mechanisms. But honestly, most importantly, operational resilience mandates transparency and meaningful human-AI handoffs. Rest assured, humans are still ultimately in the loop here. The system must know its own limits. When an agent encounters a scenario that violates its confidence threshold or breaks its operational constraints, it must gracefully pause and hand that decision right back to a human supervisor. To anchor this entire section on safety, we look to this fantastic quote highlighted in the explainer sources from Marco Argenti, the Chief Information Officer at Goldman Sachs. He states, "Responsible AI is more than a phrase, it's a fundamental business priority. As we all race toward deploying these autonomous systems to gain massive market advantages, that speed simply cannot outpace our rigorous oversight. Robust guardrails aren't just some IT afterthought anymore, they are the absolute prerequisite for even playing the game."
Well, we've covered a ton of ground today, from the react cycle of a single individual agent
all the way to the orchestration of vast multi-agent ecosystems, their internal communication protocols, and of course the critical guardrails that keep everything from going off the rails. But I want to leave you with a final thought to really chew on. As agentic AI continues to mature at this breakneck pace, creating highly capable, autonomous, robotic coworkers, how will you prepare to integrate them into your own hybrid teams? The revolution is already underway. The only question left is how you're going to orchestrate your place within it.